This sample code will allow you to display the digits 0, 1, 2, 3, 4, and 5 on the 7-segment displays on the trainer kit. And so let's go through how this code works. At the top, we have the basic include statement. This just tells the compiler that you are running the 7-segment displays on the PIC16 using the PIC16F887, and then we have some config statements. We won't worry too much about these right now. In the code that you're going to write this week, we'll just keep these config statements. We'll talk a little bit more about them later. What you're seeing here is an org statement that says the code will start at memory location 0, and then our next statement is a go to main, and that will allow us to skip over down to this main, and main starts at 8. There's a good reason that we're skipping from 0 to 8. You don't have to worry too much about that right now, but basically there is a special thing that happens in memory location 4 that will be used with interrupts. We'll talk a little bit more about those in a later lecture. And so down here at main, we're doing several different things. First of all, we're going to move into bank 1 so that we can configure our ports. And so we're clearing tris A and tris D. That will make both port A and port D, every bit of them, outputs. And then down here, we are going to do a bit set F on status RP1. That's going to switch us back into bank 3. And that way we can configure our AND cell and our AND cell H. That's going to put us into all digital mode there just by clearing both of those ports. And then we're going to get back down to bank 0. And so in an infinite loop, what we're going to do is we're going to cycle through and we're going to put the code for the different digits out onto each of the displays in order. So first of all, we have some code here which moves a literal value of 0 into W, and then we call table. And this is going to call a subroutine which will be a lookup table. And let's go ahead down here and look at the table code. So if we go down here to table, remember we just put 0 into W, and what we're going to do is add W to PCL. And if you remember, PCL is the low byte of the program counter, and we're going to put that back into the program counter. So effectively what we're doing is we're skipping ahead by however many lines are in W. And so we had 0 there. So our next code is going to go here, and so we're going to return C0. And if you remember from the previous lecture video, C0 is that 11000000, and remember that will put the values onto port D in order to display 0. The 1, the first one, turns off the decimal point. The second one turns off that middle segment. And then all the rest of the bits being 0 will turn on all of the segments in the surrounding portion of that first 7-segment. And so we're going to return this value, and then we're going to go ahead and put that onto port D. Let's go see where that happens. So we've called our subroutine, we've added the value in W to the program counter low byte, and now we've returned C0. So let's go back to where we return. And we return, remember, we popped off the stack this line, or the location of this line of code for table, and now we're going to move the value that is in W, that's that return value, onto port D. And then what we're going to do is bit clear F, port A, bit 0. And what that means is we want to turn on the leftmost digit. So the value on port D, which is going to be used to put a 0, is followed by turning on the leftmost display. And so now this code will allow us to see 0 on the leftmost display. Then we're going to call this delay subroutine. So if we go down and look at this delay, let's see what's happening. We're putting in FF into W, and then we're moving that to memory location 20. So remember, memory location 20 is not one of the special function registers. That's a general purpose location in memory. We could have just called it a counter or something like that, but in this case we're just going to use the direct addressing there of memory location 20. And then we're going to decrement what's in memory location 20, putting it back into memory location 20. And we're going to keep doing that until it gets to 0. So it started out as FF, it's going to go down to FE, and that's not 0. And so we're not going to skip, we're just going to go to -1, which allows us just to bounce back and forth. So we're going to keep doing that until this value that it was put into 20 decrements all the way down to 0. Once it does decrement down to 0, we hit the return, and then we go back. Effectively, we're just wasting a little bit of time to allow us to see that 0 on the leftmost 7-segment display. After we call our delay, then we come back up and we have a bit setf of port A, 0. That's going to temporarily turn off port A bit 0, turn off the left segment of the 7-segment displays that we have. Now we're going to go down here and do the same thing with 1. We're going to put 1 into W. We're going to call table. So we'll come down here to table, and we're going to add 1. That's going to skip over and go down to this F9. And F9 will be 1, 1, 1, 1. So that turns off the decimal point and segments G, F, and E. And then it'll have 9, which will leave zeros on the right 2 segments on that 7-segment display. So this will be the code that we will need to display 1, and then we will go back up and we will return with that value. We're going to put that onto port D, and then we're going to bit clear F port A, 1, and that's going to put the 1 on the second display from the left. And so we'll have 1 there. We'll call the same delay function that we had before, just kill a little bit of time so that that 1 can illuminate and be there for a while. And then what we're going to do is we are going to turn off that 7-segment display, and we're going to repeat the same process for 2, for 3, for 4, and for 5. And then once we finish that, we're going to go back and we're going to loop again. And so we're going to continue to do this, and what will happen is you'll turn on a 0 on the leftmost display, a 1, a 2, a 3, a 4, and a 5, and you'll just do that in a repetitive loop, and it will look as though all of the segments on the 7-segment displays are illuminated to display the characters 0, 1, 2, 3, 4, and 5. Alright?